You saw the title. This is the Lamborghini that trades asphalt for ocean. But how does a 63-foot yacht hit 60 knots without flying apart? Today you'll see the hidden supercar architecture under its skin. We'll break down the carbon fiber superstructure, the GRP vacuum-infused hull, and why keeping weight near 24 tons lets two MAN V12s unleash 4,000 horsepower on water. Stay for the Y-shaped bow lights and the Sián FKP 37Qs that turn a cockpit into a helm. You're about to learn how car DNA survives the sea. You've seen supercars chase air. This yacht fights water that is about 800 times denser, and that flips the rule book. So how does car DNA hold up when every wave hits like a pothole you can't dodge? Start with the core problem. On land, you trim grams to gain speed and feel. At sea, you shave tons to beat drag and keep control when the bow hammers into chop. The loads are not steady, they spike. Salt tries to creep into everything. You still want the same lightweight discipline, but it has to live inside a shell that can take a pounding at 60 knots without shaking itself apart. Cars lean on downforce to press tires into grip. Boats do not get that luxury. At high speed, the hull skims and can start to hop, what sailors call porpoising. Drag climbs as the wetted patch grows. Slamming sends shocks into bulkheads, joints, and mounts. A road-first mindset would set you up for failure. You need a structure that earns its lightness the hard way. So the architecture flips. The hull carries the hits. It is GRP, glass-reinforced plastic, laid up with vacuum infusion. That gives you a tough, resilient shell with fibers aligned to take the abuse. Above the waterline, the superstructure goes carbon fiber. Not just for show. You strip mass where it hurts roll and pitch the most. And you lock in stiffness where the view and the wind load live. Vacuum infusion sounds niche, but the idea is simple. You pack dry fibers into a mold, seal it, and pull resin through with a vacuum. The vacuum sets the fiber to resin ratio. You get fewer air pockets, tight saturation, and repeatable parts. It's like cooking with a scale instead of guesswork. Same recipe, same result, better strength to weight every time. Think of the carbon section as the yacht's titanium spine. It runs high and long, but it does not weigh the boat down. Like a private jet interior that stays light to keep range, the carbon superstructure keeps the center of gravity low so the hull can do its job cleanly. Less sway, faster response, more room to trim at speed. The weight target matters. Around 24 tons for a 63-foot hull shifts the whole behavior curve. It gets on plane earlier. Once up, the wetted surface shrinks, which means less drag and a calmer ride over short chop. The helm takes a lighter hand because the hull is not plowing. It's skimming with grip where it counts. Mass placement is the quiet lever. You keep heavy kit deep and centered and pull ounces out of the roof, the brow, the frames that hold the glass. That drops the center of gravity and trims roll inertia, so the boat does not lag when you steer at a 40-knot cruise. You turn, it follows. You correct, it settles. No hunting, no slow sway. Saltwater changes your material choices too. Bond lines get sized for peel and shear from slam loads. Fasteners need isolation to stop corrosion creep. Core materials in the hull panels take closed cells to block water if you do get a nick. You end up with a layered defense that stays light but refuses to soak up weight over time. This is where the hybrid build pays off. The GRP hull brings impact toughness, forgiving failure modes, and easy service. The carbon upper slashes topside weight and keeps the shape rigid under wind and wave loads. Together, they act like a truss. The hull absorbs and spreads hits. The superstructure holds geometry, so doors line up, glass seals, and the helm stays aligned under stress. The result is not delicate, it is disciplined. The structure earns the right to be light by choosing where to be strong. It puts stiffness where you steer and resilience where you strike water. That is the bridge that carries road-borne weight logic into a wet, violent world. Now that the frame holds the promise, let's turn to the next unlock. How 4,000 horsepower finds clean water, lifts the hull on cue, and stays tame as the dial rolls past 50 knots. You've got two MAN V12s on tap, a clean 4,000 horsepower waiting to move a 63-foot hull. The aim is simple: turn thrust into lift, not chaos. The control comes from how the hull and the driveline speak to each other at speed. Start with the job of a planning hull. It has to rise fast, shed drag, and hold a steady line in chop. That means you get off the displacement wall early, climb onto a smaller wetted patch, and keep clean water to the props while the bow works the short, steep stuff without slamming you into a slowdown. Past 50 knots, small trim moves carry big effects. 1 degree too high and the bow hunts. 1 degree too low and the hull hammers. Chine walk can start if lateral grip fades. Ventilation steals bite if the prop tips pierce air. Slamming spikes shoot through the frames if you hit a wave wrong. You want repeatable lift and a helm that reads true. Hull geometry is the first filter. A deep V dead rise forms a narrow, sharp entry that cuts waves instead of bouncing off of them. That entry opens into a V that still holds angle at the transom, so you keep grip in turns and stop side slip. Lifting strakes step the flow. They break suction, add dynamic lift, and feed cleaner sheets of water. Hard chines fix roll at speed and throw spray out and down, so the running surface stays dry and predictable. Now trace the power path. Each V12 feeds a marine gearbox that sets reduction in reverse, then torque flows out to high-performance propellers tuned for surfacing flow. At high RPM, the blade tips dance near the surface, where cavitation wants to form vapor pockets and strip thrust. Blade camber, cup, and diameter counter that. The cup on the trailing edge raises the local pressure, delaying cavitation and keeping a solid bite. You match pitch to engine torque curves so the motors stay in their sweet band as the boat lifts and speeds up. Cooling and breath matter at this load. The sea gives you a giant heat sink, but you still need stable intake water and clean exhaust paths under rapid throttle swings. Routing and ductwork blend into the hard lines, so the engines pull cool water and push hot gases out without feeding spray back into the bay. That lets sustained speed live inside thermal limits. Why call out a 40-knot cruise? It is a reliability choice. At that rate, the V12s sit in a band where thermal load, fuel burn, and vibration do not stack up into fatigue. Bearings stay happy. Mounts keep their torque. The hull sees repeated hits, but not the worst peaks you get near top end. You go far, you go quick, and you do not cook the gear. Take a look at the contrast. A heavy 60-footer at 20 knots drags a long wake, carries a wide wetted area, and shoves water aside with brute force. This planing 63 lifts rides on a short, firm patch and sends most of the sea under you. Less hull and water means less drag and more control from small trim and tab moves. It's a different way to travel fast. Weight ties the loop. At roughly 24 tons, the hull climbs onto planes sooner. The engines don't waste torque dragging mass through the hole shot. They push, the bow rises, the strakes engage, and the wetted footprint shrinks at lower throttle. By the time you chase 60 knots, you are already on a stable platform that wants to go there. Think of the calibration like a drivetrain map. Throttle tip-in gives measured bow rise. Mid-range brings clean lift with no porpoise. Top-end trims hold the props in solid water with no flare or sudden slip. The helm stays light but precise. You point, it tracks. You add a touch of tab and chop, the nose cuts, and the ride locks in. That's how 4,000 horsepower turns into order instead of drama. The hull shape sets the rules. The props and gearboxes translate torque without waste. The weight and balance make lift repeatable. The engineering works under the skin. Now let's talk about why the skin looks like a Lamborghini hypercar. Those Y-shaped bow lights are the tell. Sharp planes, tight cuts, and a stance that reads like speed at idle. They echo the Sián FKP 37, but the point is not cosplay. Each line cues function first, turned for glare, spray, and the need to hold shape when the sea throws a hit. You read Lamborghini's DNA at a glance. Hexagon vents, Y graphics, a driver-first layout that now lives at the helm. The language is bold, but the grammar is marine. Surfaces that look like sculpture doubled as stressed skins. Joints and seams nest into hard edges so the form hides the fixings. But here's the catch. Car styling can turn into drag on water. Hard edges trap spray that climbs the glass. Wild creases can block sightlines when the bow rises. Heavy trim raises the center of gravity and dulls your steering hand. Every choice has to earn its place or it becomes noise you pay for at speed. So the selections come with intent. The superstructure uses carbon fiber panels shaped for stiffness to weight. The angles are not guesswork. A shallow fold line boosts panel rigidity like a crease in a sheet of metal. That lets you run thinner skins without wobble. The forms hide ribs and mounting points underneath, so hardware stays out of the airstream and away from spray paths. You work the edges to serve the ride. Sharp breaks at the roofline turn downwash away from the helm. A beveled brow above the glass adds shade while bracing the frame. The side planes guide water out and down, keeping side decks drier at pace. It is visual theater on the outside, structural logic on the inside. The helm plays like a hypercar cockpit. You get a thick rim wheel with clear detents, short throw toggles grouped by task, and screens clustered in a tight arc. Your eye scans fast. Your hand lands on the right switch without a hunt. In chop, that matters more than style points. High contrast interfaces keep you ahead of glare. Dark backgrounds, bright numerals, and simple icon sets cut the time your eyes spend decoding data. Fewer modes, clearer states, and tactile clicks reduce error when the boat moves. Studies in human factors show that contrast and redundancy lift decision speed at motion, so the cues lean on that. Latency has to drop too. Engine data comes with low lag. Trim and tab feedback respond one-to-one. The screen layout mirrors the controls, so your brain maps action to result in a straight line. You steer, you trim, the nose answers. No drift, no relearn every time the sun shifts on the glass. Now back to those Y lights at the bow. They sit high for range, but the mounts pull light spill away from the windshield at night. The cut lines around the housings drain water so lenses don't haze with clinging spray. Brand signal, yes, but also a practical read on where the bow sits when your view narrows in the dark. Inside, the materials speak both worlds. Leather and Alcantara arrive with marine-grade backings and UV resistance so the color holds and the foam does not take on water. Stitch lines run where panels carry low stress, which trims extra layers in grams. You get the tactile hit without building a weight tax into the roof and cabinets. Metal touch points tone down mass. You see knurled aluminum where your hand needs grip, but the bulk of the structure uses composites under veneers. Hidden fasteners isolate dissimilar metals to stop corrosion spread. It looks clean because the engineering keeps the mess where you never see it. Take a look at the glass. The frameless look comes from deep-set frames that move the structure into the superstructure, not the seal. That keeps rigidity high and reduces flex that would pop gaskets at speed. You read it as a sleek line. The boat reads it as a brace. This is design theater with real function. A hypercar language tuned for salt, spray, and high-performance pace. You get brand cues that pull their weight and a helm that rewards your inputs. You've seen the art and the muscle. One last layer remains. The market logic that makes this 63-unit run feel like future thinking. Cut weight the right way and 4,000 horsepower stops being noise. It becomes calm, controllable speed. This 63-foot build proves it. Carbon up top, tough GRP below, and a 24-ton target give you lift on cue and a helm that stays honest at 60 knots. You value next-level innovation. Join the inner circle. Subscribe for more deep dives into design that performs. Now the tease. Diesel rules today, but the shift is on. Hybrid and electric systems are moving from labs to marinas. Should a supercar of the sea go hybrid? That answer might arrive sooner than you think.